Good morning, ladies and gentlemen. Welcome back. Today we're gonna continue our review for the semester two final. Um, we are gonna cover the topic of z-score today. All right, so make sure you have your concept and your formula sheet ready to go, as well as somewhere else that you can do some practice problems. All right. So first of all, what in the world is the z-score formula? Well, here it is. The z-score is gonna be the value minus the mean divided by the standard deviation. Now, for our purposes, we just need to know how to calculate the z-score and how to interpret that. We don't have to calculate the mean or the standard deviation. Again, just knowing what it represents. And the z-score is basically telling you how far from the data um, you are from the mean. Think about your normal distribution graph, right? Like the normal distribution graph that we talked about in the last video. The mean is in the center of the data points, assuming it's normally distributed. A z-score, for example, a z-score of 1.2 would tell you that you are 1.2 standard deviations away from the mean. This is one standard deviation. So you're probably somewhere here after the first standard deviation, but before the second standard deviation. The z-score is also used to compare different results, especially when the data is different. And you're going to see a little bit more about that in the examples. So here we go. Check it out. It says IQ scores have a mean of 100. All right. And a standard deviation of 16. Einstein, supposedly, he had an IQ of 160. Now, just when you're talking about numbers, you're like, wow, Einstein had an IQ score like 60 points higher than the mean. Some of you might be impressed, and some of you might be like, wow, like really? That's it? Like, I would assume he had like an IQ score of like 500. Well, let's see exactly how this compares when we start using z-scores. So first of all, what is the difference between Einstein's IQ and the mean? The difference, right? You're gonna be subtracting them. So if you take Einstein's IQ and you subtract it from the mean, the difference is 60 IQ points. How many standard deviations is that? Well, for that, we're going to have to take our normal distribution graph and kind of like sketch it out. Let's see if it fits. So we know the mean is 100 and the standard deviation is 16, right? So there's going to be 116, and that's one standard deviation. 132 is two standard deviations. Ooh, we're going to have to keep extending it. 148, that's three standard deviations. 154, 164. That's almost four standard deviations away from the mean. That's insane. If you remember your percentages, almost 100% of the data is collected within like three standard deviations. So how many standard deviations is that? It's more than three standard deviations. Okay, so now let's find the z-score, right? Which is going to be a simple calculation. The z-score is the value minus the mean divided by the equation first, by the standard deviation. Einstein's IQ is 160, the mean is 100, and the standard deviation is 12. 60 divided by 12 is that would be 5. If we consider an unusual IQ score to be those that converted z-scores are between -2 and 2, is Einstein's IQ unusual or unusual? Well, since Einstein's IQ is significantly greater than 2, yeah, it's very unusual. Einstein's IQ is unusual because he is more than 2 standard deviations away from the mean. Oh wait, no, we're talking about z-score because his z-score. Oh my god, what am I doing? Because his z-score is greater than 2. Sorry about that. Okay. Let's see what this next problem is all about. 3 students take equivalent stress test. Which is the highest relative score? Highest relative score. Meaning, which has the largest z-score value? Now, here is where z-score kind of comes into handy, right? Like, if you look at the 3 scores from the students, we have 144, 90, and 18. At face value, you'd be like, oh, well, the student that scored 144 has the highest score. Like, for sure, how is that even a question? But tests are different. Tests always have different difficulty. The first student took a test where the mean is 128. The second one, the mean is 86, and the mean of 15. These are the average scores. So is 144 really the highest one when you think of everybody else testing and these are the results? Well, the standard deviation is 34, 18, and 5. We're going to have to calculate the z-score for all of them. The z-score is the value minus the mean divided by the standard deviation. 144 minus 128 divided by 34. That is going to be 16 divided by 34. And let's go ahead and figure out what decimal that is. That is approximately 0.47. That is your z-score. Now for the next student, I'm going to skip the formula because it's right there already. We have 90 minus 86 divided by 18. That's 4 divided by 18, which is 0.22. And the last student scored an 18, but the mean is 15 and a standard deviation of 5. That would be 3/5, which is 0.60 or 0.6. And there you have it. C, the student who scored an 18 on a test in which the mean was 15 and the standard deviation was 5, that student's z-score is significantly higher than the other ones, right? So relative to everybody else, student C scored the highest one. That is how you can use z-score to compare results where data is vastly different. All right, thank you. Good luck in your studies. Let me know if you guys have any questions.